Good morning everyone. Example 10 is given here. Find the intervals in which the function f given by fx is equal to x square minus 4x plus 6 is strictly increasing and strictly decreasing. So in this question we have only the function. We don't have any interval where we have to check the increasing and decreasing. So for this, first of all we have to find the derivative of fx. So derivative of fx will be 2x minus 4. Now since we don't have any interval in our question, we have to find the interval. So for that we have to find the point where the function fx is a constant function. So we know whenever f dash x is equal to 0, then at that point the function is constant. So first of all we have to consider that f dash x is equal to 0. If f dash x is equal to 0, from here we will get x equal to 2. So at the point x equal to 2, fx is a constant function. So since our given function is defined for all real number, that means the domain of this function is the set of real number, and this set of real number is divided in two parts. One part is minus infinity to 2, another part is 2 to infinity. Since at this point the function is a constant function. Now we will check whether the function is increasing or decreasing in these two intervals. So first of all we will consider minus infinity to 2 open interval. We know with infinity and minus infinity we always use open interval, but with 2 here also we are using open interval because in our question it is given strictly increasing and strictly decreasing. Whenever we have strictly increasing and strictly decreasing, we always use open interval. So in minus infinity to 2, from this interval we will choose a number. Suppose in this interval we have 0. So if we put 0 in fx, then f dash x will become negative. So f dash x less than 0, f is strictly decreasing. So to check a function is increasing or decreasing to a particular interval, we have to choose a number from that interval and we have to put here, and we have to check that f dash x is negative or positive. If it is negative, then it is decreasing. If it is positive, then it is increasing. So if we put 0 here, then it will become minus 4. So it is less than 0. So f is strictly decreasing. In place of 0, you can take any number which is in this interval. Now if we check for this interval, we can take suppose again 4. If we put here 4, then it will become plus 4. So it is greater than 0. So f is strictly increasing. Here I have given negative sign because of decreasing, and here I have given positive sign because of increasing. So for this we can choose any number from a particular interval and we can put it in place of x in this f dash x, and we can check it is increasing or decreasing. Example 11. Find the intervals in which the function f given by fx is equal to 4x cube minus 6x square minus 72x plus 30 is strictly increasing and strictly decreasing. So here also we don't have any interval, and we know fx is defined for all real numbers. That means the domain of the function is the real number. So we have to check for every real number. So first of all we will find the derivative of fx with respect to x, and f dash x will become 12x square minus 12x minus 72. Now we will find the point at which fx is a constant function. So for that we have to consider f dash x is equal to 0, then we have to find the value of x. If we consider f dash x is equal to 0, then from here we will get x equal to minus 2 and x equal to 3 by doing middle term. Now we have the domain from minus infinity to infinity, and we have found that x equal to minus 2 and x equal to 3 where fx is a constant function. So this whole interval minus infinity to infinity is divided into 3 interval. One interval is minus infinity to minus 2, another is minus 2 to 3, and the last one is 3 to infinity. Now we will check whether the function is strictly increasing or strictly increasing in these 3 intervals. In this type of questions, first of all we have to find the derivative, then we have to consider this f dash x is equal to 0, then we have to find x, then we have to divide the intervals among these 3 intervals. Now if we consider minus infinity to minus 2, we can choose any number from this interval. So if we choose the number is suppose minus 3, then we have to check f dash x is greater than 0 or less than 0. So other than putting the value of x equal to minus 3 here, we can put here also. It will be easier for us because from here only we will get this line. So if we put here minus 3 will be minus 6, and from here minus 3 plus 2 is minus 1. Now we don't need to find the value, we have to check only it is increasing or decreasing, that means it is greater than 0 or less than 0. Since this part is negative and this part is also negative because of x equal to minus 3, so if we multiply these two, this whole will become positive. That is why f dash x is greater than 0, so f is strictly increasing. Since it is strictly increasing, that is why it is only greater than, not greater than equal to, and here it is the open interval because of strictly increasing. Now to check for this interval, here also we will choose a number and here we can choose 0. So if we put 0 here, this part will become negative. If we put 0 here, this part will become positive. Negative into positive is negative. So f dash x is less than 0. So f is strictly decreasing. Now for the last interval 3 to infinity, we can choose a number. Suppose if we choose 5, so if we put here 5, then this part will become positive. If we put here 5, this part also become positive. Positive into positive is positive, so f dash x is greater than 0, f is strictly increasing. So for these two intervals, f is strictly increasing, and for this part f is decreasing. Example 12, find intervals in which the function given by fx is equal to sin 3x where x belongs to closed interval 0 to pi by 2 is increasing or decreasing. So here we have the interval 0 to pi by 2. Now first of all we have to find the derivative of fx. So f dash x equal to 3 cos 3x. Now next step is f dash x equal to 0. From here we will get cos 3x is equal to 0. Now from here, if x belongs to 0 to pi by 2, then we can write it like this. Since it is a closed interval, then we can write 0 is less than equal to x less than equal to pi by 2. X belongs to 0 to pi by 2, then where will be 3x? So from here we can find if 0 less than equal to x less than equal to pi by 2, we can multiply 3, so it will become 0 less than equal to 3x less than equal to 3 pi by 2. So whenever x belongs to 0 to pi by 2, 3x belongs to 0 to 3 pi by 2. Now if cos 3x is equal to 0, what will be the value of x? Because we have to find the value of x so that we can find at which point fx is a constant function. So if cos 3x is equal to 0, 3x can take which values? We know whenever x equal to pi by 2 or 3 pi by 2, then cos x is equal to 0. That means odd multiple of pi by 2. That means whenever x equal to 2n plus 1 pi by 2, where n is an integer, cos x is equal to 0. So if we put n equal to 0, then the value will become pi by 2. If we put n equal to 1, then the value will become 3 pi by 2. So pi by 2 and 3 pi by 2 we got. Now if we put n equal to 2, then it will become 5 pi by 2. But 5 pi by 2 we cannot take because 3x belongs to 0 to 3 pi by 2. So 3x can take the values pi by 2 and 3 pi by 2 only. Now if 3x is equal to pi by 2 and 3 pi by 2, what will be the value of x? Value of x will be pi by 6 and pi by 2. So in this way we have to find the value of x. First of all we have to find the derivative, then we have to write f dash x equal to 0. From here we have to find the value of x. Since we have a condition that x belongs to 0 to pi by 2, first of all we have to find where is 3x. So 3x belongs to 0 to 3 pi by 3. Now since 3x belongs to 0 to 3 pi by 2, so for cos 3x equal to 0, 3x can take which values? 3x can take pi by 2 and 3 pi by 2. If 3x equal to pi by 2, then cos 3x is equal to 0. If 3x equal to 3 pi by 2, then cos 3x equal to 0, considering this interval. So from here we will get x equal to pi by 6 and pi by 2. Now in our question the interval given is 0 to pi by 2, so we have to do the question considering this interval only. So here we have written 0 to pi by 2 and it is divided in two intervals. One interval is 0 to pi by 6, another is pi by 6 to pi by 2. Since we have two values of x, one is pi by 6, another is pi by 2, in this line we can put only pi by 6 because pi by 2 is only the extreme point. Now we will check that the function is increasing or decreasing in these two intervals or not. So if we consider this interval, then if x belongs to 0 to pi by 6, if x belongs to 0 to pi by 6, that means we can write it like this. Then 3x will belong to pi by 2. So if 3x belongs to 0 to pi by 2, that means in the first quadrant, then cos 3x will be positive. If cos 3x is positive, then 3 cos 3x is also positive. I am repeating, if x belongs to 0 to pi by 6, then 3x belongs to 0 to pi by 2, that means in the first quadrant. Since 3x is here, that means cos 3x is greater than 0. Since cos 3x is greater than 0, 3 cos 3x is greater than 0. If 3 cos 3x is greater than 0, then f dash x is greater than 0. That means strictly increasing. Why we are telling strictly increasing? Because here we have given the open interval and only greater than, not greater than equal to. But in our question we have to find only increasing. Whenever the question is given to find it is increasing or decreasing, we have to close the interval and greater than equal to. Because at x equal to pi by 6, that means 3x equal to pi by 2, 3 cos 3x is equal to 0. So it is greater than equal to 0. Now we will check for this interval. So if x belongs to pi by 6 to pi by 2, then 3x will belong to pi by 2 to 3 pi by 2 by multiplying it by 3. Since 3x belongs to in these two quadrants, so cos 3x will be negative less than 0. So 3 cos 3x will be also negative. So f dash x is negative. So f is strictly decreasing in this interval. Whenever we are telling strictly decreasing, here we have taken open interval and here only less than. For decreasing, we will close the interval and less than equal to. Now for 0 and pi by 2, we will always use closed interval because it is given in our question that x belongs to the closed interval 0 to pi by 2. We will change the intervals with pi by 6 only for increasing strictly increasing, decreasing strictly decreasing. So to find that a function is increasing, strictly increasing or decreasing or strictly decreasing, first of all we have to find the derivative of that function with respect to x. Then we have to write f dash x is equal to 0. Then we have to find the value of x from there. After that we have to put the value of x in the interval so that the interval is divided into some intervals. Then we have to check that in different intervals fx is greater than 0 or less than 0. So accordingly it is increasing or decreasing.